Well, hey there, kiddos. Today we are going to be working with our foldables again. We're going to talk about the next three parts that are on your foldable, which have to do with the multiplication properties of exponents. There are three of them, and the first one we're going to talk about is what's called the product of powers. It's when I have two powers with like bases. Base is the big number being taken to the exponent. If I have two powers with like bases and they are multiplied together, that's a product of powers. And I want to do a simple example first of something to sort of help you see what's going on. So if I do 2 squared times 2 to the 4th power, I'm going to expand this out so you can see what's going on. 2 squared is the same as 2 times 2, and then 2 to the 4th is 2 times itself 4 times. And if I take all those 2's I just wrote and rewrite it as a new expression, I have 6 of them now, so it's the same thing as 2 to the 6th power. And so if you'll look at my exponents, the only way to end up with a 6 from a 2 and a 4 is that I added those two numbers together. And so that is my rule for product of powers. Okay, so when you are multiplying powers with like bases, you just simply add the exponents. Now, if they do not have like bases, you can't do anything with them. It's like adding an x plus a y and making it an xy. They have to be like bases. They have to be the same in order for you to add their exponents. So like a here, I have 5 to the 10th times 5 to the 23rd. Well, that's the same thing as 5 to the 10 plus 23. And when I add up my two exponents, that becomes 5 to the 33rd. And we can simplify that even more. You could actually multiply that out on your calculator and get it, but that's going to be a rather large number, so we're going to leave it as an exponent. B here also has same bases. They're both y's. I got y to the 7th and y to the 4th, so I'm going to add those exponents. I end up with y to the 7 plus 4, which is the same thing as y to the 11th. Now when you look at C, I've got 2 to the 0, 6 to the negative 2, and 2 to the 5th. These have like bases, so I can add them together. But I cannot put the exponent with the 6 with either of those because it is not the same base. So I end up with 2 to the 0 plus 5 times 6 to the negative 2. Well, 2 to the 0 plus 5 is just 2 to the 5th times 6 to the negative 2. And if you'll remember from our lesson yesterday, negative exponents are not okay, so I have to move this into the denominator. So this becomes 2 to the 5th over 6 squared, and I can simplify that even. And then I can simplify that by actually finding out 2 to the 5th is actually 32, and 6 squared is 36, so it becomes this fraction 32 over 36, which will also simplify. I can divide both of those by something. So 4 will go into both of those numbers. I can divide 32 by 4, which becomes 8, and I can divide 36 by 4, which becomes 9, and so simplified, that is 8/9. This is an acceptable answer, leaving it with the exponents, but since these are reasonable numbers, we're going to go ahead and simplify them and write them down. This one in A, 5 to the 33rd, even if you plug that in your calculator, you're going to get something written in scientific notation because it's a large number. Now look at D. I'm going to let you try that one on your own, so pause for a second, see if you can come up with the answer, and then come right back. So hopefully you added your exponents, the 2 plus the 5, and you came up with negative 8 to the 7th power. And again, I can simplify that, but this is also a rather large number, so we're just going to leave it as negative 8 to the 7th power. So that is product of powers. If you have two powers with like bases, you just add up their exponents when you're multiplying to simplify it down. The next version is called power of powers, and that's when I have a power like 4 to the 3rd, already taken to another power. And so these almost always involve parentheses happening. And so when I do a power of powers, so when I have a power raised to another power, then I get to multiply the exponents. This is sort of like distributive property, only using the exponent. So if you look at my first example here, I have 4 to the 3rd power, all to the 3rd power. It's got parentheses. The 4 to the 3rd is in parentheses, and a whole thing is taken to the 3rd. I get to distribute this little exponent outside to all the exponents inside, and so it's just a multiplication problem. And so I'm going to multiply, and this will become 4 to the 3 times 3, which is 4 to the 9th power. And I can leave it like that, or I can use my calculator and simplify, and it's a big number, but it's not really big. It comes out to 262,144. Excuse me. Either one of those is an acceptable answer. However you choose to write it is fine. They're equivalent, so they mean the same thing. Now part B here is just a little bit different. I have 3 times x to the 4th to the negative 2 power. Well, the only thing that's being raised to a power is the x to the 4th, not this 3 right here. And so the only thing that this negative 2 is going to get distributed to is the 4 that's in there with the x. The 3 stays out here, so I have 3, and then I'm going to multiply these exponents, so I have x to the 4 times negative 2, which becomes 3x to the negative 8, and again, no negative exponents are allowed. This 3 does not have a negative exponent. It's got an exponent of 1 on it, even though it's invisible and I can't see it, so it gets to stay, but the x to the negative 8 has to move into the denominator, so it's positive. So now let's talk about C. I have this whole thing, negative 6 squared to the 5th. There are parentheses here because I want this entire negative 6 to be squared, and then I want the whole thing taken to the 5th power. Well, I'm going to distribute my exponents just like before. So I have negative 6 to the 2 times 5 power, which is the same thing as negative 6 to the 10th power. And I can actually use my calculator and work that out. And again, it's a rather large number, so we're going to just leave it like this. But remember, if the whole thing is in parentheses with that negative, then it means the negative is being taken to that power also. And since it's an even power, it will make my number positive. If it were an odd power, then my number would be negative. Talk about our last rule that has to do with the multiplication, and it's called power of a product. That's when I have a product, so I have two things being multiplied, and all of that is taken to a power. This is a lot like the last rule that we just did with the power of powers, except that I'm going to have more than one thing being raised to the power. And so in this case, it's still a distribution. I'm going to multiply exponents, and I'm going to be distributing that exponent into everything inside the parentheses just like before. So like example A, I have x times y to the 4th power. This x has an exponent of 1 and this y has an exponent of 1. They're not written, we don't write them down, just like we don't put the 1 in front of the number, we also don't write it as an exponent. But I can still multiply by distributing my exponent. I have to distribute the 4 to this one, and I have to distribute it to this one. So this becomes x to the 4th, y to the 4th. I just multiplied and distributed that way. So if you look at B, it works the same way, but you got to be really careful because you got a negative 4, b to the 5th. These are two separate things. This negative 4 has an exponent of 1. This b also has an exponent of 1. It's just like the xy, only one of your things happens to be a number. It still counts when you are having to multiply and distribute that exponent. So I have to distribute that 5 to both things. So I end up with negative 4, and I'm going to leave it in parentheses because it was in parentheses to begin with, to the 5th power, b to the 5th power. And if I wanted to simplify further, I could do negative 4 to the 5th power and come up with the fact that is negative 1024, and it's negative because I had an odd power, b to the 5th. So if you look at C is a little bit different because there's a negative outside of the parentheses and then there's everything inside. Well, again, all of these pieces have an exponent of 1. So I'm going to distribute, and I have to distribute 3 times this time because there's 3 parts in there. So I have negative 5 to the 3rd power, x to the 3rd power, y to the 3rd power, and I'm going to simplify this. Negative 5 to the 3rd power becomes negative 125 x to the 3rd, y to the 3rd, but this negative and that negative cancel each other out, so I have 125 x to the 3rd, y to the 3rd. That is in simplified form. So now let's deal with D. There's an invisible exponent of 1 here, so I'm going to distribute this 2, so I end up with 2 to the 2nd, x to the 6th, because I have to do 2 times 3. All of that is times x to the negative 4. Well, now I have like bases. And so I have x to the 6th and x to the negative 4. So now I have to add those exponents. So I have 2 squared times x to the 6 plus negative 4, which is just squared. And when I do 2 squared, that's 4, so this becomes 4x squared. I could have moved this x to the negative 4 down into the denominator and dealt with it that way, but we haven't talked about division with exponents yet, so you would not have come up with exactly the same answer that I did. So I would just add my exponents together and hope that it works out the negative. If it doesn't, then move things. But I would add my exponents together first. So that is our 3 properties using multiplication. We will practice this when you come to class tomorrow, and I will see you then.